Okay, this is the last topic in mathematics, data analysis. And when you're talking about data analysis, you're just talking generally about how to interpret data, how to see graph or diagrams, statistical drawings or data to make prediction and analysis. So there are a lot of ways you can do that. And let me start with frequency distribution. Now, well, I know you are familiar with all of this, but I will still at least do my job by explaining to you. Let's say we have data, like a set of data. I can tell you to, for example, now, one appears more than one. One, two, three, four, five. So according to this distribution, five appears five times. So that's the frequency, how frequent one is, and some other variables here. So let's just treat this by topic using an example. A survey was taken to find the number of children in each of 25 families. A list of the variables collected in the survey follows. So this is the list here. Now, let's say here are the resulting frequency and relative frequency distribution of the data. Now, what they are just trying to do here, they're just trying to show you how data is being represented on a table. Now, these are for example, these are the numbers from 0, 1, 2, 3 to 5. So they just wrote the numbers out and then write the frequencies in number of times it appears. So, for example, they are saying according to this distribution, 0 appears 2 times. You count this here 1, 2, 3. That's what 3 is here. 1 appears 5 times. I counted it the other time. 2, according to this distribution, we appear 7 times. So if you count the number of 2 that is here, it's going to be 7. Same thing with 3. 3 appears 6 times. 4 appears 3 times, and 5 appears 1 time. So by the time you add this together, you're going to have 25. That's the frequency of that distribution. If you add the whole frequency together, it's going to be 25. So that's what they said. So the number of children in each of 25 family. Now, let me show you relative frequency distribution. Relativity means when you are comparing something to another thing. You understand? Now, if you are going to get the relative frequency of this based on this data, this is the raw data 0 to 5, 0, 1, 2, 3, 4, 5. Our relative frequency is going to be 3 divided by the total frequency, which is 25 times 100 for 0. So that's how they have 12%. Let me see if I wrote that down. So, okay, I didn't write it down. So, the relative frequency for 1 here will be 5. This is 5. This is the frequency over 25 times 100. That will give you 20%. The same thing happens to 2. 7 divided by 25 times 100 will give you 28%. Same thing goes for 3. 6 divided by 25 times 100 gives you 24%. And then the last one, so no, this is second to the last, 3 divided by 25 times 1, 3 divided by 25 times 100, that gives you 12. And the last one, 1 divided by 25 times 100, that gives you 4%. Now, if you add this percentage together, it must give you 100. So this is relativity, relative frequency. This is frequency. I'm just using this to explain to you. I know you are familiar with this, but I just need to, show you some of this thing myself. You understand? Now, let's talk about bar charts. Now, this data analysis is just talking about how data has been represented. So, that's what I'm trying to show you now. So, what they note that the total for the relative frequency is 100%. If the decimal were used instead of percentage, the total would be 1. So, they're saying that if, for example, 12% is 12 divided by 100. So, that can be decimal. That can be 0.12. I guess, yeah. 0.12. Here will be 0.2. So if you add everything together, it's going to be 1 if it's in decimal. But here it's not in decimal, it's just in percentage. So that's what they're talking about here. Now, bar chart. Bar chart is just another way of representing data, information. You understand? And let me use this example. Look at this table. in the GRE, they're going to give you a lot of table for you to interpret. They will ask question on the table. They said for 2009 enrollment at 5 colleges. These are the 5 colleges: college A, B, C, D, and E. Now, what's the meaning of this data? If you look at college A, these are the number of enrollment, right? So it is obvious that based on this graph or this chart, we have 4,000 people enrolled in college A in 2009. Then college B, if you look at it, it's like in the middle of 4,000 and 5,000, so it's going to be like 4,500. So 4,500 enrolled in college B. If you look at college C, it's a bit close to 5,000, but not up to 5,000, very close. Let's just say 4,900, yeah, or 4,950. So that's the range. So college C has that. Then let's check college D. Based on the data, it's a little bit more than 6,000, but it's not even up to, let's say this is 6,500, right? It's not up to that. It's very close to it. Look at the graph. So let's just say 6,400, 6,450, around that range. So I'm not accurate with it. You just have to get to know the information. So, and this one is talking about this last one, which is the highest. It has its own, let's just say around that 7,500, because it's like in the middle of 7,000 and 8,000. So that is that about that. So let me read what I wrote down. From the graph, we can conclude that college with the greatest for 2009 enrollment was college E, and it's obvious, is it? And the college with the least enrollment is college A, and this is it. Also, we can estimate the enrollment for college D. College D was about 6,400. Let's college D is okay. So about that, they're not even to about, so it's around that circumference. So that's all about. So the most important thing, the skill they want to understand or they want to get from this particular topic is for you to your ability to understand data. That's all they want to know, and how to use it to solve problem. So there are different. Another. I want to show you another type of graph, bar graph, and this one is segmented. This one is not segmented. It's normal bar chart and straightforward one. But this one is segmented, and based on this graph, still using it the fall 2009 enrollment at 5 colleges again. You're still using the same example, but here there's a partition. They told you here that the one in this white box has full-time. These are full-time people or students, and the one with colored box is part-time. So based on this, you can say that college A has 1,000 part-time students. However, this white space is going to represent the full-time. If I had to calculate for the full-time using this bar, what I'm going to do is just simple. Just look for the highest value, which is 4,000, right? And this 4,000 consists of full-time and part-time. Since you know that of part-time, so you just have to deduct 4 from 1. That gives you 3,000. So based on this graph, this particular one, you have 3,000 people that are part-time and 1,000 people that are full-time. So the addition makes 4,000. Or if you don't want to do it that way, but that's an easier way, you can actually calculate it from here to here 1,000. From here to here another 1,000, that's 2,000. From here to here, that's 3,000. So that's another way. But the way I explain is the best really. I can't have the time to start seeing everything, but let me just continue. This second one here, college B, if you look at it here, so 1,005. So that's a 1,005 part time, and you don't know this one. For us to get this one, you have to know for the total. The total here is 4,500, right? 4,500 minus 1,500 is going to give you the number of full time here. You understand? Now, the same thing goes to college C. The part time is going to be 2,500. And if you look for the total, it's very close to 5,000. Let's just say 4,900. So 4,900 minus 2,500, that gives you the full time, and the part time is 2,500. And you do the same thing for to this space. College D, it has, let me check, not up to 2005, but let's just say 2,200. Yeah, 2,200 full-time student, and this place for us to calculate the white one, which is the full-time. Let's look at the total, which is 6,000. Let's say 6,300. 6,300 minus 2,200. That will give you this, the answer here for the full-time. Then the last one here is going to be let's look at it. The full-time. Look at the box. So as I told you, this is the part-time. Part-time is shaded. So the shaded one is what? Let me check. Let's say about 3,500. That's for the part-time. Then for the full-time, this one is the white one. So let's say for the total. The total here is around 7,500. So 7,500 minus 3,500. That gives you the number of full-time students. So that's that. That's just the interpretation. For you to be able to interpret it, you get. So they can be asking a question in their own different ways, but then if you know this, then you can get it. So if you read below here, it's the same thing I just explained here that they will talk about here. Now, this is another bar chart. This one is see the same thing. They told you for 2019. This one is like for 2019 and spring 2010. Sorry, for 2009 and spring 2010 enrollment at 3 colleges, college A, B, and C. Now, here, this is the key. They said 4 is represented by the colored box. This other box here is for spring 2010. So now, look at the arrangement. This is the number of enrollment, right? College A for 2009, that's 4,000. For the spring, it has spring 2010. It has about, let's just say 3,800. So that's that. Then for this one too, for 2009, it has the total package enrollment of 4,000. Let's just say 4,500. 4,500. Then for here, for the spring 2010, it has, let's say 3,700. Let's give you an estimate. I'm not calculate it. You look at it here. For college C, we have about 5,000, but up to 5,000. Let's just say 4,900. Yeah, or 4,950. Either of the two will work. Then for here, this is so close. Spring 2010. We're going to give you around, let's say 4,800 or 4,850. So that's that. So your ability to interpret or analyze or explain, to give meaning to what you to this figure, to this chart, that's what you want to test here. And let me quickly talk about circle graph. So circle graph is not talking about. So circle graph is just talking about a circle which is divided into different parts. Now look at this. They say United States production of photographic equipment and supply in 1971. So they said the total is 3,980 million. So this is the total. So they now gave you percentage. Census that good 47%. Office corpus 25%, 4% for this, 7% for that, 12% for this, 5% for that. So now this is divided into different partitions. Now, since this is the total value, right, you can actually calculate the value for each goods or supply. For example, 47% of this amount will give you the actual amount for this. 25% of this amount will give you the value of that is 25 over 100 times this total amount. That will give you this value of this. 4% of this total amount will give you the value for this. 7% of the total amount will give you the value of this. 12% of the total amount will give you the value of this. 5% of the value of this total value will give you that. So it has their own different values. So in case you encounter something like this, you should be able to work it. Percentage is just 5. This 5%, for example, is just going to be 5 over 100. You need to use percentage over 100 times this value, and it gives you the answer. The answer will be inputted in the box. And that's all about another thing I want to tell you about this is that each part of this circle is a sector. For example, this is a sector, 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 this is a sector. Because so that's what I want to tell you. Thank you for your time.